Welcome to Saucy Math. This is going to be all about polynomials and doing operations on polynomials like adding or subtracting or multiplying polynomials. So the first example I have here is actually a subtraction of two polynomials. Now when you're adding or subtracting polynomials, basically what you want to do is combine the like terms together, which means collect together the terms that have the same variables raised to the same exponents. The one thing to watch out for is if you're subtracting, like with this one, since you're doing this first polynomial, 3x squared plus x plus 1, minus this second polynomial, 2x squared minus 3x minus 5, you want to make sure you distribute that negative into that entire second parentheses. So you want to distribute that negative sign to all the terms in your second parentheses. So what we end up with then is going to be 3x squared plus x plus 1, and then minus 2x squared. All right, we're going to have minus 3x, so that's going to be plus 3x. And then minus the negative 5 is going to be plus 5. All right, that's the biggest mistake that people make on a problem like this, is just making that minus go to the 2x squared and then not distributing it to the other terms in that second parenthesis. So just watch out for that, because like I said, it's a huge mistake that people make all the time. And once you distribute that negative, now like I said, it's combining like terms. So we start off with the 3x squared term, and we also have this minus 2x squared, right? They both have x raised to the second power, so that makes them like terms. And just do what the numbers say. 3 minus 2 gives us 1x squared, which I'm just going to write as x squared. All right, then we have the x terms. We have a plus x here and a plus 3x here. So it's 1x plus 3x, so that's going to be plus 4x. And then we have the constant terms, the terms that don't have the variables. All right, we got the plus 1 and the plus 5, so 1 plus 5 is 6. So what we end up with then is, if I just write this a little clearer here, x squared plus 4x plus 6. All right, that's what we get when we subtract those two polynomials. All right, the next example I want to look at is multiplying two polynomials. And the method we can use to multiply this, you may have heard of it as the FOIL method. Basically what we do is we take this first polynomial, we multiply the 7y, distribute that to the second parentheses, the 2y and the minus 1, and then we take the other term in that first parentheses, the minus 3, and distribute that to the 2y and the minus 1. Right, so, and if you notice the FOIL method, the F in FOIL stands for the first terms, the 7y times the 2y, which is going to equal 14y squared. All right, when you multiply y times y, you add the exponents. 1 plus 1 gives you y to the second power. Right? Then the O in FOIL stands for the outer terms, the 7y times the minus 1. So 7y times negative 1 is going to be minus 7y. And then the I in FOIL stands for the inner terms, the minus 3 times the 2y. So negative 3 times 2y is going to be minus 6y. And then the L in FOIL stands for the last terms, the negative 3 times the negative 1, which is going to work out to be plus 3. All right, so if you remember the FOIL method, that's all we're really doing here. And we'll see this in the next example, but basically what we're doing is we're taking the 7y, distribute that to all the terms in the second parentheses, then take the minus 3, distribute that to everything in the second parentheses. And then the only thing to do after that is to collect any like terms together. And with a problem like this, a lot of times, those two middle terms we can combine together, right? The minus 7y and the minus 6y, those are like terms, so we can add those up to be minus 13y. So we get 14y squared minus 13y plus 3. All right, that would be our answer to that one. All right, and then the last example I want to look at is another one that involves multiplying polynomials, but this one is a little bit different from that last one. Right, the last one, the two parentheses each had two terms in them. This one, the first parentheses has two terms, but the second one actually has three terms. But if you think so we can't really use the FOIL method here, but if you think of it as distributing, then it's pretty simple. Right, so start with the first term here in the first parentheses, which is x, and we're going to distribute that to everything in the second parentheses. So it's going to be x times 2x squared, x times minus x, and then x times plus 1. All right, so x times 2x squared is going to be 2x to the third power. The x times the minus x is going to be minus x squared, and the x times the plus 1 is going to be plus 1x, or just plus x. All right, so that's distributing that first term to the entire second parentheses. Then we do the same thing with the next term. We take that plus 1 and distribute that to everything in the second parentheses. So it's going to be 1 times 2x squared, 1 times minus x, and 1 times plus 1. All right, so 1 times 2x squared is going to be plus 2x squared. 1 times minus x is going to be minus x. And 1 times 1 is plus 1. All right, so we got all our terms now. And the last thing we need to do, just like that last example, is combine the like terms together. All right, so we have a 2x to the third power, and we don't have any other x to the third power, so there's nothing to combine with that one. It's just 2x to the third. Then we've got a minus x squared and a plus 2x squared. So a minus 1 and a plus 2 adds up to a positive 1. So that's going to be plus 1x squared or just plus x squared. We have a plus x and a minus x. So a positive 1x and a minus 1x, those are actually going to cancel out and add up to 0. And then we have the constant term at the end, the plus 1. So we end up with 2x to the third plus x squared plus 1 when we multiply these two polynomials.